Hi, everyone. Welcome to Chapter 7, which is on energy, work, and power. Well, this week, I think you're going to really enjoy it because energy, work, and power mathematically are a lot less complicated than so many of the things that we've been doing. And a lot of people find them fun because of the fact that we're going to be able to do similar problems than we have done in the past, but kind of from a totally different technique in a totally different way. Energy is going to give us a whole set of tools that we haven't had before. It's also very topical in the fact that energy is important in the modern world, conservation of energy. How do you get different types of energy, and how does one form of energy transform into another? Law of conservation of energy is one of those big conservation laws in all of science. It's useful in chemistry and biology, any kind of science, environmental science. It's just a big deal. So a fun and interesting topic. Let's go forth and take a look at our module in Canvas and see what we've got. We're going to start with work. Now, when we talk about physics work, we're going to talk about applying a force through a distance, which is much different than working hard on your physics problems. I know you think a lot, you move your pencil a lot, but that's a different sort of thing. Physics work means applying a force and making something move. You don't move something, you don't have any work done. Now, after we talk about work in a typical week in a typical module, we are also going to have a study guide. We've got some homework problems, and we're also going to talk about power. Power is defined as how fast a job is done. So if you have a 100 horsepower engine and a 200 horsepower engine, the 200 horsepower engine will do the same job twice as fast. So power is how fast the job is going to be done. Energy is all those lovely different kinds of energy, wind and solar and electrical and hydroelectric. All of those produce joules of energy. And what do we use energy to do? To do work, to move things through a distance, and how fast we do those is power. So we're going to calculate different transformations of energy, and then we're going to talk about efficiency. How much energy do we get out of a machine or a system compared to how much energy we put in? At the end, I'm going to skip and talk about the end of the chapter, then we're going to come back and talk about the lab. The end of this chapter, we're going to have a combined test over chapter 6 and 7. So this is all of the information about rotation and gravity and energy, work, and power. So we're going to have a concept quiz, 30 points there, and a problems test, 100 points there. So 10 questions, multiple choice that are math, and then 10 questions, 3 points each, that are the ideas and definitions. So let's take a look at our lab for this week. Our lab for this week is pretty easy to take data for. This is called the Bouncy Horsepower Lab. And when you're doing this lab, you're going to need an assortment of balls that bounce. In your lab kit, you should have a tennis ball, the acrylic ball, and then you're going to make a ball out of clay. Please feel free to remove or replace any of these with any other ball that you might have floating around your house. Golf ball, ping pong ball, small rubber ball, etc. The only thing is they have to be small enough that you can find their mass on your small balance. What you're going to do is take the ball, drop it, and then measure its rebound height. So you're going to measure its original height and then how high it rebounds to. One of the questions people ask is, where do you measure it from? Well, you're going to measure from the bottom of the ball to the bottom of the ball, because the bottom is what's going to actually hit that floor. You're going to take 3 different types of balls, bounce each multiple times, find an average, and then with that information, you're going to calculate the original potential energy at the first height, the kinetic energy right before it hits the ground, velocity before hitting the ground. That you're going to record or move into this column the average height of that rebound, calculate that potential energy after rebound, and then determine which one of those balls is the most efficient, conserves the most amount of energy. And just sort of follow the little yellow brick road of questions through the lab, and they should lead you through most of the situations you've got going on. Part 2 of the lab, we're going to talk about work done. How did the ball gain energy in the first place? What was the source of the original energy? And then part 3 is all about horsepower and climbing stairs. So if you have a set of stairs in your home, in your apartment, climb that set of stairs. You're going to measure the vertical displacement, time yourself going up those stairs, use that data to calculate your horsepower in watts and horsepower as you climb those stairs. Now, some of you are panicking right now thinking, I don't have stairs. I live in a very flat house. How am I going to do this? Well, right here, there's some information about a typical set of stairs that are in a home. I got this information for a domestic situation. This is not a commercial set of stairs. And you can use this information to calculate that vertical displacement. Once you've done that, I'm going to ask you to do a couple wacky calculations, like how many food calories do you burn? And then personally, I'm very fond of strawberries. So how many strawberries would you burn if you climbed that set of stairs? And then how many watts of power and horsepower you calculate. So the data taking is very small. Most of this is just practice using the equations that you are going to be looking at through the entire chapter. So have a good week. All of this information is going to be on the test, so I highly recommend that if you can, do the lab before you take the test. It will help. It's good practice. Have a super week. Please be in touch if you have questions, and we'll talk soon. Bye-bye.